All right, hey guys, this is Mrs. Van Newland, and we are going to be finishing up lesson 1.4, which talks about graphs of proportional relationships. So we already did some things with this, so we're just going to kind of continue it. All right, quick warm up. If I have these 5 graphs, could you tell me which ones are proportional and which ones aren't and why? So I'll just give you a quick second to think through those 5, and then I'll go through it. All right, so remember, for a graph to be proportional, it has to be a couple things. It needs to go through the origin, so it has to go through 0, 0. Second thing, it needs to be linear or a straight line and have a constant rate, which kind of connects to that anyway. So those things need to be the case. So if I look at letter A, it does look to be linear. You guys can see that. And it does go through 0, 0. So this one is proportional, so I'd say yes. Second one, it's a straight line, but it does not go through the origin, so it is not proportional. Letter C goes through the origin. It's a straight line, so yes, that one is. Letter D, it does go through the origin, but it doesn't have a constant rate the whole time. You can see it's going up at this rate for part of the graph and then this rate for the other part, so no, it's not. It is not proportional. And letter E, it does go through the origin again, but this is not a line, this is a curve. So it's not going at the same rate. It doesn't have a constant unit rate, so it is not proportional. All right, so then this is what we're going to talk about today. It's trying to find the constant of proportionality from a graph. So first thing, just a quick review. Constant of proportionality, that's really just another word for unit rate. I want to know how much it is for just one. Okay, so if I have a proportional relationship, that is, if it goes through 0, 0, and it's a straight line, and it has a constant rate, okay, so a unit rate, we want to try to find that. And again, that's called the constant of proportionality. The letter they use for that is the letter K. That's kind of the abbreviation they use for constant of proportionality. So a quick way to find the constant of proportionality from a graph, or the unit rate, there's a couple different ways. So the first thing is you can always go to the point 1 comma something. So right here, that's going to tell me after for 1 second it went 5 meters. Now, I don't know if that's a perfect point there. So if I don't have a dot there, then I'm not going to use that way. What I can do is go to the point that I do have. You guys can see I have this point. I have 2 comma 10. I also have 3 comma 15. I also have 4 comma 20. What I can do for all of those is I can divide those out and do the y divided by the x. And here's why. The y coordinate, if you guys look here, that's the distance. Okay, so I'm doing the distance divided by the time. So it's always y divided by x, because that will give me how far he goes, the meters per second. That's why I divide the y per x. So if I had this first point, I'll write in a different color, 2 comma 10, I'm going to take the y coordinate, that's x comma y, I'm going to do 10 divided by 2. I'm going to do 15 divided by 3, 20 divided by 4. And you notice each time I do that, I end up with 5. So my constant of proportionality in this problem is 5. That's also my unit rate. Okay, so if I just ask you for the constant of proportionality, you'd say 5. If I asked you for the unit rate, you would say, oh, this, whatever it is, goes 5 meters per second. So I just found the constant of proportionality, or the unit rate, from this graph. Now, the only exception to this is 0, 0. That does not work. If I divide 0 by 0, you can't actually do that. So it's for all points except 0, 0. So you can test any point on the line, and it should give you, if you divide it out, it should give you that 5. If not, it's not proportional. So again, the only point you can't test is at 0, 0. So let's check out another problem. We have an example here. It says in a 100-meter race, we're going to assume that the runner's rate is constant. That means he's running at a constant rate the whole time. Now, obviously, he's not going to be perfect at that, but we're just going to kind of assume that. And it says the distance run is proportional to the time spent running. So if we look over here, I can see a couple things. It does go through 0, 0. It is a straight line, and it actually tells us it's proportional. All right, so in the problem, it wants us to find the constant of proportionality. So I want to try to find that. So again, constant of proportionality, just another word for that, is the unit rate. How much per 1? So let's look at the situation and see what we want to find. What per what? Okay, so a little hint, it's always the y per x. So I want to find the distance he goes in meters per second. Okay, that I usually even write that out. I'm trying to find how far he's going, how many meters per second. That's going to give me my constant of proportionality, or my unit rate. So I can take the y divided by the x. So I'm going to just go ahead and find a nice point. Okay, so I see 5, 30 on my graph. Okay, that's probably the nicest ones. This one I can't really tell what it is, nor can I tell that one exactly. So I'm going to use the one, actually, let me just erase this. Actually, none of them are real nice on the line, but they actually tell us a couple of them, which is nice. So they tell us that this one is, you can see it right here, 5-31. Usually we'll tell you what those points are if they're not nice. And then this one is 10, 62. So to find my constant of proportionality, I'm going to take the y coordinate divided by the x. So I'm going to do 62 divided by 10, 31 divided by 5. I should get the same number each time I do that. And good news, I do. It's 6.2. So my constant of proportionality is 6.2. Okay, now if I want to say what that actually means, I have to say, okay, what's the unit rate? Well, that would mean that this runner is running 6.2 meters per second. So if it says describe it, that's what you would need to do to describe the constant of proportionality. So there's my two answers. I listed it and then I described what it meant. All right, let's check out my next one. So it says Brianna decided to save money each week for her family vacation. Use the graph to find the constant of proportionality, and then I want you to tell me what it means. So I want you to pause the video and I want you to try this one out and see what you get. Push play when you're ready. Okay, so first thing, remember it's always the y per the x. So I look at my y label. I'm trying to find the money per, if I look at my x label, week. That kind of helps me when I have to describe it. So I'm going to pick a point and I'm going to just divide it. So I know in 2 weeks she saves $40. So to find 1 week, I'm going to do the y divided by the x. So 40 divided by 2 is 20. Let's check that on my other one. So I know in 4 weeks she saves $80. So to find how much per week, I do 80 divided by 4, which is also 20. So notice I get the same number. So my constant of proportionality is 20. All right, second thing, you have to tell me what that means. Well, if you write this out, it kind of gives you what it means. So I got 20, so it's she saves $20 per week. That's what the constant of proportionality means. So she saves 20 bucks every single week. Now again, we know this is proportional. It goes through 0, 0, straight line, constant rate. All right, if we look at the next part of the lesson here, it says you also are going to need to be able to analyze points on a graph. Okay, so that means if I give you a proportional relationship, you're going to need to tell me like what some points mean. Okay, so like this point 0, 0, that's kind of special. We're going to try to figure out what that means if I give you a situation. And then this point right here, during a graph, if you ever have the point 1 comma something, that's going to give you the unit rate. So that would be like if this was time, like after 1 second, the R stands for the constant of proportionality or the unit rate. So that's why they call that point. It's special. If that's on the graph, it's really nice. It actually gives you the unit rate. So if it was 1 comma 5, it might mean she runs 5 meters per second. If it was 1 comma 10, 10 meters per second. So that's always going to give you your unit rate. And then the point 0, 0, this is always going to kind of tell you the same thing. It might say if it's time, it'd be like after 0 seconds, she runs 0 meters. So basically, it's always going to be after 0 something, it goes 0 something. So we'll take a look at that as well. So let's take a look at this example. It says, we'll kind of read along here, the number, I'm just going to get my pointer, the number of students on a school trip is proportional to the number of teachers as shown in the graph. Okay, so they're telling us it's proportional. You can see it's a straight line. It says the line representing the relationship is a dashed line. Okay, well, I'll talk about that in a second. So first thing we want to know, what do the points 0, 0 and 1 comma 25 represent? So we're going to have to look at those and see what they represent. Okay, so first thing, 0, 0 right here. Okay, let's look at our label. So 0, 0. My X is the number of teachers. So that would mean for 0 teachers on the trip, there are, the Y coordinate is the students. There are 0 students. Okay, so that's what that point would tell us. All right, next one we want to say, so what does the 0.1 comma 25 mean? Well, it's going to be the same thing. This is the x coordinate, this is the y coordinate. So x, if you look there, that's the number of teachers. So that would be for every one teacher, there are 25 students. Okay, so if I was going to do the constant of proportionality, I would say, okay, it's always I want to know how many students per teacher. Students per teacher. So if I look at this, I have 1 comma 25, so I do 25 divided by 1, which is 25. I could also do this point, 100 divided by 4, which is also 25. So my constant of proportionality is 25. My unit rate is there's 25 students per teacher. I just kind of abbreviated that. So you just analyze those 2 points. All right, let's go ahead and I'm going to have you pause the video and I want you to try this problem on your own and then push play when you're ready to see me go through it. All right, it says the cost of a smoothie is proportional to the number of ounces as shown in the graph. So first thing I always just kind of look at is, remember, it's the y per x. So it's always this per this. So I already know it's going to be the cost per ounce. That's what I'm kind of looking at. I want to know what is the cost per ounce. Okay, so let's look at the first thing. Let's see if we can find the unit rate. So to find the unit rate, remember, you take the y divided by the x. So it looks like here it's 0.5 divided by 1, which is 0.5. If I come up here, I'm going to do 2 divided by 4, which is 0.5. Now this is money, so I'm going to add a 0 after that. So that would tell me it costs 50 cents per ounce, right? For 1 ounce, it tells me 50 cents. So I kind of could see that right there. For 1 ounce, the cost is 50 cents. Okay, so first one, it says, is the unit rate 0? Well, no, the unit rate is 50 cents. Okay, second one, it says the unit rate is 0.5. Well, yes, that is correct. All right, third one, the unit rate is 1. No, that is not right. Okay, I'm just Xing out the ones that are wrong. It says for each smoothie, it costs $1.50 for every ounce. Nope, it's only 50 cents. For each smoothie, it costs $2 for every ounce. Well, for every ounce, it's 50 cents, so no. For each smoothie, it costs $1 for 2 ounces. Okay, well, let's even just look at the graph. Right here, it is $1 for 2 ounces. Because if it's 50 cents for 1, then it'd be $1 for 2 ounces. So this one I am going to circle. And then it says for each smoothie, it costs $2 for 4 ounces. Okay, well, let's just think. For 3 ounces, it'd be $1.50. For 4 ounces, yep, it would be $2. All right, we have one more, just kind of putting everything together from this lesson. So it says the heights of 2 plants are recorded after 1, 2, and 3 weeks. And the data is shown in the table. Which ordered pair represents a unit rate for the number of inches grown per week? Okay, so I've got 2 plants, plant 1 and plant 2. Okay, so if you look at, let's just focus on plant 1. I see 0, 0. That means after 0 weeks, it's 0 inches, right? 0 weeks, 0 inches. Okay, so far that makes it proportional. After 1 week, it's 5 inches. After 2 weeks, it's 6. After 3 weeks, it's 7. I want to know if that's proportional. Okay, well, there's a couple ways you can kind of check it out. First way, you could be like, okay, here, it's going up by 1 every time. Okay, but over here, it went up 5, and then it's going up 1. Is that the same every time? And it doesn't look like it. That's probably not proportional. The other way you can do it is divide the y by the x. So if I do 5 divided by 1, I get 5. 6 divided by 2, I get 3. 7 divided by 3 is, oh, I can already tell those are not the same number. So this is not proportional. Plant 1 is not. Okay, let's look at plant 2. We'll do it a couple different ways. Okay, so first thing I can see, it goes through 0, 0, so that's good. And over here I can see, okay, it's going up week by week. Here it goes up 3 after the first week, another 3, another 3. So it looks like it's going to be proportional. Okay, but let's test it out. So 0, 0, again, you never test. 1, 3. So let's do the y divided by the x, I get 3. 2, 6. Do 6 divided by 2, I get 3. And 3 comma 9. 9 divided by 3 is 3. I got the same thing every time, so this one is proportional. And I would say, hey, it grows 3 inches per week, because that was the unit rate I found. And then my constant of proportionality is 3. All right, so now you're going to practice this a little bit in your next activity.